Okay, so this topic might be maybe boring to some of you if you are familiar with the topic of derivatives and maximization thing. But if since you know what I've done the same course last semester. I've taught it last semester, but it was in person, and I felt like many of the students needed to know more about the derivatives. So it might be challenging for some of your friends. That's why I'm explaining it today. But if you are familiar with the derivative stuff, you can and if you're gonna leave the meeting, you're free to go, right? That's all we are gonna discuss for today. So the entire microeconomics, let's say, or the entire of this course, or let's say the baseline of this course is to maximize the profit of a firm, right? So whenever you've heard I'm saying optimization or optimal decision or maximization, it's entirely based on maximizing the profit of the firm, right? So maximizing the profit is the baseline of the entire course, right? So and for the entire course, we are interested in how we can maximize the profit. By how, I mean what should be the optimum price and optimum quantity that maximizes the profit, right? So that's the entire problem. That's the baseline of this course, right? The profit has two parts: revenue minus total cost, right? Revenue is a function of price and quantity, and cost is a function of quantity, right? So if you're going to expand the revenue, it's price times quantity. And if you're going to expand the total cost usually has two parts. The first part is a constant or a fixed cost, and the second part is the variable cost, right? Variable cost is something which depends on the quantity you are producing. The fixed part is whatever you need to pay at the beginning, let's say for starting the new business by buying the building, equipment, machinery, facility. The entire cost related to this is called fixed cost. And variable cost is whatever you need to pay per unit you are producing, right? So it's a function of Q. On the revenue side, price and quantity, as I've already explained on the recording, the relationship between price and quantity, it's explained under demand curve and demand function, right? So we can write down the price as a function of quantity, A, which is a constant, minus B, which is a slope, times Q. Like a function like this would explain the relationship between price and quantity. Whenever we are going to maximize or minimize, or generally speaking, whenever we are going to optimize a function, what we do in economics is that we take the first derivative of that function with respect to the control variable. The variable we can change to make the function maximize or minimize, right? For example, here we are going to maximize the profit, and the control variables are P and Q, right? And since P and Q are kind of related to each other, we can explain the relationship under the demand function. We can use one of them only for the derivative, right? And usually in the economics, we use the Q, right, to take the derivative. So what we do when we are going to optimize a function is that we take the derivative of that function with respect to the control variable, and we put that equal to 0. By doing so, we are going to end up with an equation, and from that equation we can extract, for example, Q star, right, or the optimum value for the control variable. And then by putting that control variable, the optimum value for the control variable, back into the profit function, we can find the maximized profit, right? So other than that, in terms of notation, so this taking the derivative and putting that equal to 0, finding Q star and P star, in economics, it's called marginal analysis. So this entire thing, it's called marginal analysis, and we apply the marginal analysis to find the Q star and P star in optimization problem. Under marginal analysis notation, the derivative of anything with respect to Q, it's called marginal of that thing. For example, the derivative of profit with respect to Q, it's marginal profit. It's called marginal profit, right? Now, I'm going to expand this profit function, right? The profit is revenue minus cost, right? So it's revenue minus total cost, and then the derivative with respect to Q, and then one more step, the derivative of revenue with respect to Q minus the derivative of total cost with respect to Q, right? Again, under marginal analysis notation, this is called marginal revenue, and this is called marginal cost, right? So the equilibrium condition, or let's say the optimization condition, says that this equation should be equal to 0, right? Which means marginal revenue should be equal to the marginal cost, right? So this equation is the equilibrium equation for the optimization problem. And that is what you need. You don't need the entire proof. You don't need to know, don't need to show me in the exams or assignments how we can derive this equilibrium equation, but you need the equilibrium equation itself, right? So for any optimization problem, the equilibrium condition is marginal revenue is equal to marginal cost, right? And marginal revenue is the first derivative of revenue with respect to Q, and marginal cost is the first derivative of total cost with respect to Q, right? So yeah, that was what I wanted to add to today's lecture, or the last week lecture. Do you guys have any question about the derivatives or anything about this? Nope.
I was wondering if you could do an example, like with real numbers.
Yeah, sure. I think we can use the examples we had on the lecture. Let me find the lecture. Okay. So as an example, for example, let's assume the demand function is P equal to 100 minus 38Q, right? And then how about the cost function? Let me find the cost function here. The cost function is, or could be, for example, let's say 400, it's just a hypothetical thing, plus 2 times Q. right? So then let's write down the profit. The profit was revenue, which was Q times P minus total cost function, right? So if I'm gonna put these into the revenue into the profit function, then it's gonna be Q times 100 minus 38 times Q. And then that minus the cost function, right? Then I would take this into the parentheses, then it's going to be 100 times Q minus 38Q squared. And then minus 400 minus 2Q, which is going to be negative 400. Then plus 98Q and minus 38Q squared, right? So I'm going to maximize the profit, right? So the problem is maximizing the profit, and what would be the Q and P, the price and quantity that maximizes the profit, right? So I'm going to use Q, and then I would take the first order derivative of profit with respect to Q, and I will put that equal to 0. So it's going to be the first derivative of profit, and that should be equal to 0. It's going to be the derivative of this function up here, negative 400 plus 98Q minus 38Q squared. And that would be with respect to Q. Now, the derivative, let me go to the next page. Let's see how we can go to the next page. So the derivative of a constant with respect to any variable, it's going to be 0, right? Then the derivative of the second term, it's 98. The second term is 98 times Q. The derivative of that term, it's going to be 98. And the last term is a second order degree term with respect to Q, and the derivative of that one, it's going to be negative 2 times 38Q. And this should be equal to 0, right? So you can see here we have an equation, and the only unknown variable in this equation is Q. We can simply extract the Q, the value, or the equilibrium or optimum value for the Q, right? It's going to be, so the optimum value for the Q, it's going to be 98 over 2 times 38. Right? So that's how we can find Q star. And after finding Q star, we can use the demand equation to find the P star, right? Demand equation, it was P equal to 100 minus 38Q, right? So after finding Q, we can put the Q star value into this equation, and then we can find the P star value. right? Any question? David?
What happened to minus 400? Because the equation was the derivative of minus 400 plus 98q minus 38q squared.
You mean in derivative? What happened to that one?
Yeah, because you brought it down on
Yeah.
from the other page, and then all of a sudden it just became q plus 98.
Yeah.
What happened to the
So,
minus 400?
yeah, minus 100, that is a constant, right? The derivative of any constant with respect to any variable, it's 0, right? So the derivative of any constant with respect to any variable, it's 0, and that's here, it's 0.
So that disappeared and became 0.
Yeah, because it was a constant.
So it can be only 100 or it can be any number.
For what?
Like the ones that we are speaking about, the 100. Let's say we're gonna have another examples. It's all the time will be 100 something q, or it can.
Oh no, it's different. For sure, it depends on so many factors.
So it depends, but in the calculation we kind of assume that it's 0.
If it's fixed, if it's a constant term, like here, it's a constant term, right? It's 0. So what I did over the next page is that I took the derivative of each term separately. So the derivative of this term with respect to q is 0. The derivative of this term with respect to q is 98, because 1q is appeared here as the multiplication, right? And the derivative of the last term, q, is here, it's a second degree order, right? So the derivative of the last term with respect to q is 38 times this one minus this one. Right? So you can find more detail on the derivatives on math textbook, or you can come to my office hours and ask your questions.
How about the derivative of q on the denominator? Is it canceled out?
You know what? It's just a notation. I mean that for the notation's sake, we are writing down the derivative of q down there, right? So writing down the derivative down there is just saying that we are taking the derivative of this function with respect to this variable.
But the formula for to maximize the profit is derivative of the profit over the derivative of q is equal to 0, and therefore if you do transfer the r minus the total cost over dq, it should be this value. But then when you cancel that's why I was confused, where does the derivative q on the denominator
So you know what?
happen?
By the equilibrium condition or by optimum condition, I meant you should take the derivative of that function with respect to the variable which is in the denominator and put that derivative equal to 0. That's exactly what we did, right? We took up here, this is actually the derivative of profit with respect to q, right?
Correct.
And we put that equal to 0.
Yeah.
Right? So we take the derivative of the function which is in the numerator with respect to the variable which is on the denominator, and we put that equal to 0.
Okay, and that's why the 2 times 38 becomes positive
2 times 38
38
becomes
on the
positive.
denominator.
You mean here?
Yeah.
Yeah.
Sorry, I wasn't sure how did you get 2 times 38 on your formula in the earlier page.
Yeah, that's actually the derivative characteristic. For example, let's use like a general function, right? For example, we have a function of f, right? It's a function of x, right? It means f is equal to a is as a constant plus b, right? It's also constant times x the first degree order, plus c also constant times x squared, second degree order, right? I'm going to take the derivative of this function with respect to x, right? So the derivative of any constant, the first term, with respect to any variable including x, that's 0, right? The derivative of the second term with respect to x, it's x in the second term is first order degree, right? So what you do usually when you are taking the derivative is that you, for example, the order of this x is 1, right? What you do when you are taking the derivative, so this term is 0, for the second term it's b times the order you have up here, which is 1, right? So I just don't want to make you let me change the variable. X may not be a good one. Let's use another variable. X might be confusing. Let's use q, right? So f is a function of q, and then c, and then q squared, right? So what you do when you are taking the derivative of this function with respect to q, the derivative of any constant with respect to q is 0. The derivative of the second term with a q with a first degree order, right? The power of q there, it's 1, right? So what you do is that you take that power back to the variable, so it's going to be b times 1, right, times q, then that power minus 1. I do the same thing for the last one. It's going to be c, then I take the power back there, times 2, then times q, the power minus 1, right? So if you calculate this one, then it's going to be b plus 2cq, right? So that's why
Gotcha.
that c actually comes from, right?
Okay, got it. Thanks.
Great, no worries. Any other question? Nope, no question. Okay, great. So that's all I wanted to tell you for today. Now I would stay here until 8. If you guys have any question, you can stay and ask your question. Otherwise, you are good to go.
Hello. I have a question.
Yeah, sure.
Yeah, I couldn't get the calculation of Q star. Could you repeat that again? How did you calculate that? Like, how did 2
This
multiplied by
part,
38 came?
this part.
Or maybe just do another example from the beginning. So to
This one, you mean? That was actually an example. If you want me to do it from the beginning, I can do it quickly, or you can review the recording. So in the question, let me see what was the function. So in the function, the demand curve, it was P equal to 100 minus 38 Q, and the total cost function, it was 402 Q. Plus 2Q, right? So that means the profit function is 100Q minus 38Q squared minus the total cost function, which is 400 minus 2Q, right? In the reduced form, it's negative 400 plus 98q minus 38q squared. So I'm going to take the first derivative because I'm interested in the q that maximizes the profit, right? The problem is what q and p, right, would maximize the profit, right? So I take the first derivative of the profit function with respect to q, and then I will put that equal to 0, right? So the derivative of the first term, which is a constant with respect to q, is 0. The derivative of the second term, it's 9/8. The degree of this term is 1 times q 1 minus 1. Minus the derivative of the last term, the degree is 2. 38 times 2 times q 2 minus 1, right? And then this should be equal to 0, right? So then if I'm gonna simplify this term, it's gonna be 0 plus 98 minus 2 times 38q and equal to 0, right? So we have an equation, and the only unknown variable in this equation is q, right? So I'm gonna take the q term to the other side. So it's gonna be 98 equal to 2 times 38 times q, right? So from here, I can extract the q term. Q is going to be equal to 98 over this part, 2 times 38, right? Clear? Any question?
Clearly, some of us are struggling with this, me included. Do you have any suggestions or recommendations of where to go to get additional practice and support?
Yeah, you know what? If you go to the course syllabus, there are some textbooks that could explain these additional material you need, including core econ, right? But I think specifically you need more textbook or additional sources on derivatives, which is more math. So let me see if I can find any free source on the derivatives, and then I would upload it on Canvas. That would be the basic derivatives on math.
Much appreciated.
Yeah, no worries. Any other question?
So just in this particular equation, you would still want to solve for 2 times 38, for example, like breaking it down even further, correct?
Yeah, you should just calculate this. You don't need to break it down. You just need to calculate it. Let me tell you exactly what would be the final answer. 98 divided by 2 divided by 38. It's gonna be 1.29. That could be the answer.
Perfect, thank you. I was just wondering, we still have to, finish the equation, basically.
I know. Any other question?
Hey, Sadaf.
Yeah, hi.
I'm just wondering how much calculus, like for derivatives, should we review? Like
Just this
like
much,
just
like
this much.
example. Yeah,
So no chain rule product like that.
yeah.
Okay. So okay.
That's
Perfect.
all
Thank
you need. Yeah, no worries. Any other question?
Yeah.
Hi. Question?
Hi, Sadaf. Are you referring to me?
Yeah, Ian?
Okay, yeah, that's right. That's right.
Yeah,
Awesome.
go ahead.
Just a quick, can we quickly go through the equations that you posted on from the notes? I don't need any explanations. I just want to see how your methodology and how you went about it.
This example or
No, from the notes.
oh, from the notes. Like the equation. Let me pull up the.
Thanks.
Yeah, no worries. Can you tell me where? Which slides?
Yeah, so basically, I just wanted to find out because I did try to work out the equation. Your
This
final
equation?
the profit equation.
This one?
Yeah, I tried to,
Uh-huh.
I got a different profit equation using the cost and revenue. So can you do the exact same thing with these equations like you did with the examples from the class tonight?
Yeah, but the cost function is not introduced in the lecture, right? Did you use the same? How did you get the cost function?
Well, I didn't have an idea. So I was wondering if this profit equation was that done arbitrarily in terms of are there missing
Yeah,
factors?
yeah,
Okay, gotcha. That's what I wanted to find out because I couldn't get the same
yeah.
one.
And the example I just reviewed, it's not this one. It's just a hypothetical case.
All right. Okay, now that makes a lot of sense. Well, good.
Good.
Thank you very
Yep.
much, Adaf.
No worries. Any other question?
Going back to the example that you just did in class on that whiteboard, the
Mhm.
1.29, can you very briefly, I guess, explain what that means verbally in terms of just that number itself?
Oh, you mean the last step?
Yes, just like the 1.29, what does that mean exactly? Like you have the number, you have the calculation, yes.
So
And you said it's to maximize
that
profit.
is only the calculation you can do by any calculator, including your cell phone, right? It was I don't have that part saved, but I think it was 98 divided by 2 times
38.
right? So that's you can calculate it. I just did it by my phone.
No, so I'm asking if like that Q, like that 1.29 that you got for this when you did that calculation, what is it like? What does it mean? Quantity equals 1.29?
Yeah, that's quantity. That's units, or if it's like depending on the type of the product, it's just a quantity. Yeah.
So that's the 1.29 is a quantity that you need in order to maximize profit. Is that how you? Okay.
Yeah. And sometimes, for example, for some product, depending on the type of product, 1 point something doesn't make sense. It should be either 1 or 2, right? So then you can decide between 1 or 2, or you can calculate your profit for 1 and 2 to see which one is greater. I mean, practically.
Okay.
Hi, Sadaf.
Yeah, hi.
I just want to confirm that 1.29 is like where the slope is equal to 0.
What the slope?
Sorry, like 1.29 is like where x is equal to where the slope is equal to 0 on the function curve. Yeah.
No,
Oh, okay.
the slope in that function, I think. What I don't remember the function because I've already don't have them saved. The slope, I think it was 38, right? If you're referring to the demand function, right? This is the demand function, right? And the slope of this demand function is negative 38. It's not 0.
But 1.29 is like on the x, like, sorry, never mind. I think I get it.
1.29, that's units of the product, right? Quantity.
Okay, I got it. Yeah, thanks.
No worries. Any other question?
Sorry, just to confirm, there's no reflection paper expected for today's.
No, starting next week.
Okay, thank you.
Yeah, no worries. Great. If you guys have no more questions, then we are done for today. I will upload the material for the following week by tonight on Canvas under week 2. And then you can go and review the recordings as well as the lecture, and then we can discuss it more next week on Tuesday. So have a good week and see you next week.
Thank you.
Thank
Thank
you.
you.
Bye.
Thank you.
Thank you.
You.
Thanks.